Hello, welcome to Business Calculus, Chapter 5, Section 4. Today we get the fundamental theorem of calculus. And it sounds intimidating, but really it just means f of b minus f of a, and we can actually just get a number that represents the area underneath the curve. And so we're going to be dealing with a definite called a definite integral, so we're not going to have a c anymore, plus c, like we did in section 5.3. Today we're going to get a number or an answer with no constant. Remember, a is always the lower limit, so it's going to go from low to high. And then it's kind of weird. We're going to do f of high minus, which is kind of backwards maybe, f of high minus f of low. So is the fundamental theorem of calculus. So today the objectives are to understand how to find area underneath a curve and explore the fundamental theorem of calculus, and then look at it as a business marginal analysis examples. And we're also going to be finding the average values of functions and using properties for even and odds, and talk about annuities. So this is a long video, I apologize in advance. So again, here's the definition. The fundamental theorem of calculus is that f of b minus f of a. And here's the definition of the integral, talking about why it's the area underneath the curve. And again, there's that f of b minus f of a. The fundamental theorem of calculus is what we're learning today. And again, the fundamental theorem of calculus finds the area underneath the curve, which you've never been able to do before you've taken calculus. And then this is kind of a proof of what's happening for the area underneath the curve and why that works. And you're welcome to read through those slides for the proof of why f of b minus f of a works, but I'll leave that reading up to you. So again, when you hear the fundamental theorem of calculus, think f of b minus f of a. And just remember that a is down here, so you start with the top, f of the top minus f of the bottom. And really, you would literally just integrate this thing. We know the integral of x cubed is x to the fourth, and then sometimes it's just evaluated between 1 and 3. So then there's your f of 3 minus f of 1, and f of 3 is right here, minus your f of 1, and there's the fundamental theorem of calculus. The c's can be dropped because of this reasoning right here. You've got a plus c and a minus c, so I don't have to worry about the c's anymore. So again, f of b minus f of a, all of my rules will still work, even though it's not an indefinite integral. These are called the definite integral. So when I have definite integrals, I'm actually going to get an answer or a number for the area underneath the curve. So here we go. This says use geometry for our very first example. And I see this is a triangle, and the area of a triangle is 1/2 base times height. So I'll take 1/2. The base of this thing is 2. The height of this thing looks to be 4. And the area turns out to be 4. Now I could have used the fundamental theorem of calculus by integrating this thing. The integral of x is, of course, x squared 1/2, and of course I have a 2 out front, so it's just x squared evaluated between 0 and 2. And then I could use the fundamental theorem of calculus as f of 2 minus f of 0, and f of 2 says go to the f function and plug in a 2. So it's 2 squared minus 0 squared, which again is 4. So either way works. So if you can't use geometry, just showing you that since this is a triangle, we can use geometry, but in some figures you can't use geometry. So again, this answer was 4, easy enough, but this I can't use geometry because this is a nice little curve here. So it looks like a triangle, but it's not. It's the x squared minus 1 function, so it's not a straight line. So this says find the area bounded between 1 and 2. So I'm going to integrate x squared, that function, between 1 and 2. So to integrate this, I'm going to set this up, and let's look what's under here. There's the setup for this. So after you set it up, you have this, and I'm going to start integrating. And I'll integrate each part here. The first part is the integral of x squared, which is x cubed. Divide by that, minus. This is really x to the 0, so if I increase it, that's an x, because the derivative of x is just a 1. And I evaluate that between 1 and 2. So then I do my f of 2 minus f of 1. And f of 2 is 1/3 2 cubed minus 2 minus my f of 1, which is 1/3 1 cubed minus 1, and I start number crunching. So this is going to be 8/3 minus 6/3 for right in here, which is a 2/3, minus this guy, which is 1/3 minus 3/3, which is a negative 2/3, which pops out 4/3, because minus and negative changes to a positive. Here's how the author works this out, and they also get 4/3. For this next problem, I cannot break this up. I cannot distribute this. That's huge no-nos. And so I think I'm going to have to use maybe a little bit of a u sub. So let's let u equal 4t plus 1, which is a skill we've learned in the previous videos. The derivative, even though I'm taking the integral of this thing, I'm going to take the derivative over here, 4 dt, and divide through by 4, and get 1/4 du is substituted for dt. So this dt is really 1/4 du, and then I'm going to pop out that 1/4. So I've got 1/4 the integral of some du, and then this was my u squared. And so to integrate that, I get 1/3 u cubed, and that 1/4 is still hanging out there. And of course, then I'll just plug back in my u value, which is t squared plus 1. But let me show you something neat. I could change the parameters and evaluate this not between 0 and 1. No. 0 and 1 only work for the t variables. So I would highly recommend, you don't have to do it this way, but I'd highly recommend that you just throw the 0 into your u sub and find new parameters, because they're no longer 0 and 1. So if you throw a 0 in there, that's 4 times 0 plus 1, which is 1. And then if you throw a 1 in there, you get a 5. So you could evaluate this thing between, in fact, if you wanted to, this is 1/12 times u cubed evaluated between 1 and 5. So that 1/12 just kind of hangs out front. Might be the easiest way to do it. So 1/12 times, oh my gosh, 5 cubed, 125, minus 1, which is 125 minus 1 is 124, and 1/12 of 124 is 10 and 1/3, which you may write as 31/3. So there's other ways to work that problem, but I really like changing the parameters to your u. Now, if you didn't do that, you're always welcome to go back. So this was a 1/12. Go ahead and plug that u back in for 4t plus 1, just to show you that this does work as well. I wouldn't recommend this, but some students like to do that. They just like to go back to the t because they don't have to worry about the parameter. And let's see, that thing is still being cubed, right? And then evaluate that back to your t between 0 and 1. So just for fun, let's see if we can number crunch this too. So if I plug in a 1 there, that's 4 times 1, which is 4, plus 1, which is 5. I still get 5 cubed minus, so 1 cubed, and I get the exact same thing. All right, so you're going to get the same answer either way. I really just think it's easier to change the 0, 1 to a 1, 5. Let's see. The author does not do that. They keep 0, 1. But they get the same answer as we do. 31/3. So either method would work. A couple more examples. If you remember the integral of e to the 2x, you're going to have to do a u sub, let u equal 2x, so du equals 2 dx, and divide through by the 2. So 1/2 e to the 2x gets evaluated between 0 and 3, and I would just do the fundamental theorem of calculus right here. Just leave that 1/2 hanging out front. So this is e to the 6th minus e to the 0, and e to the 6th I would just going to leave 1/2 e to the 6th. If you this is a 1/2 e. This is a 1, so minus 1/2, because when you distribute that, I don't know if you want to go decimal or not for that. There's the exact answer. This guy, the integral of 1 over x is the ln of x, and then evaluate that between 1 and 2. So it's the ln of 2 minus the ln of 1, and if you remember, the ln of 1 is 0, so I would just say the ln of 2. We'll see if the author goes decimal here in just a moment. I'll pop out a -3 and integrate this between 1 and 4 of x to the 1/2, changing that square root to be x to the 1/2. Increase this exponent 1/2 by 1 to get 3/2. Divide by it 2/3. Well, instead of dividing by 3/2, we'll multiply by 2/3. And of course, this is times a -3, which cancels. So I'm left with -2. The fundamental theorem of calculus, let's throw a 4 in there. Oh my gosh. 4 to the 3/2 says take the square root of the 4 and then cube it. So 2 cubed is 8 minus 1, because it doesn't matter what you do. 1 to the 3/2 is still just 1. And that turns out to be a 7, and -2 times 7 is -14. Well, that's kind of interesting. Can area be negative? And the answer is yes, because that just means it's underneath the curve. So I hope they explain. Oh, they just went decimal form here. I had the exact answers, and yep, the ln of 2, and for this one, yep, -14. But again, I wanted to talk, up until now, negative area did not make sense, but it just means that I've got area underneath the curve. So that's what negative area means. Here's my x, here's my y, and all of this area. Or, I might have some area above and some area below, so maybe this is above and then this area is below, but the total is -14. So this is the positive area, this is your negative area, and there's more negative area than positive area. So that kind of leads me into the absolute value problem and how to work an absolute value, which is really 2 problems in one. So I'm going to think about this being area 1, think about this being area 2, and kind of integrate. So this equation of the line is the negative part. Remember, if I have the absolute value of x, then y is equal to x, or negative x is the definition. So we're going to find that vertex, to find that point right there. And to find that vertex, I'll just set that 2x minus 1 equal to 0. So 2x equals 1. So the vertex is x equals 1/2. That's that point right here, 1/2 comma 0. So I'm going to integrate then between this guy. It starts at 0 and goes to 1/2. And then I'll add, that's area 1. And then I'll integrate the 1/2 to, looks like all the way to the 2 for area 2. But remember, area 1, the formula for that is not positive slope, it's negative slope. So there's the negative part of that, and here's the positive part of that back to this definition, why that works. And so I'll integrate, I'll just pop out the negative. 2x minus, and then go from 0 to 1/2. And then I'll add from the 1/2 to the 2, the 2x minus 1. So let's go ahead and integrate. They look similar, but the a and the b terms, the f of b minus f of a, will be very different. So integrating this becomes x squared plus x, and I'm going to evaluate that between 0 and 1/2, and I think I've got a negative still floating out front, right? Yeah, because that's negative x, and so, okay, I think that's right. Keep me honest here. So this is x squared minus x from 1/2 to a 2. So the fundamental theorem of calculus, plugging in a 1/2. 1/2 squared is 1/4 with that negative out front, plus 1/2. Minus, well, this will all be 0. So that's my f of b minus f of a for that first part. and then plus, now let's do the f of 2 minus f of 1/2. So when I plug in a 2, of course I get these two terms, 4 minus 2 minus the 1/4 minus 1/2, and that becomes a number crunching nightmare. But I think that number crunches to 5/2. So go ahead and just add negative 1/4 and all of that in yellow. Should turn out to be 5/2. Let's see what the author says. Maybe he does a little bit better job of explaining it. Yay, at least he gets the 5/2. We may say marginal, that's the derivative, and if they give you the derivative, of course, we have to integrate it to find the exact. So we're going to go backwards this time, and they're giving me the marginal profit, and they want to find the change in profit. So to do that, we're going to integrate. And it looks like in part A, we're going to integrate from 100 to 101. So for part A, I'm integrating from 100 to 101 of the negative 0.0005 x plus 12.2x. And integrating that, I get negative 0.00025 x squared plus 12.2 x, and then evaluate that between 100 to 101. So the fundamental theorem of calculus here, I'm going to plug in the f of 101 minus the f of 100, and I would just pull out my calculator and start number crunching this. And I think this turns out to be $12.15. Let's see if the author, yep. And for part B, we do the exact same thing, but from 100 to 110, and evidently we get 121.48. So the next thing we're going to talk about is the average value function, and just like you would find the average of your test scores, if you got an 80 and then a 92 and a 90%, and then divide by 3, you would divide by 3 the total number of numbers. Well, if you're integrating from A to B, the total distance would be that b minus a, the high minus the low. So it's 1 over, that's what this 1/3 is, right? You're adding up all of this. This is all of the sum, and that's what this area is, adding up all of those little rectangles underneath the curve. So it's infinitely many rectangles underneath the curve. Those are all the sums, and then the distance is from is that 1/3 part. So the average value kind of makes sense. You just throw the 1 over b minus a out front when it says average value. Otherwise, everything's the same. You still integrate. So in this case, we're going to integrate from 0 to 24. So the 1 over b minus a would be the 1/24. So in other words, you just find the area, and then to find the average of that, you just take 1/24 of the area, or times the area. So in this case, I've got 1/24. To find the area of this, I'm going to integrate between 0 and 24 of this guy. Oh, good golly molly. Why do they use such crappy decimals? So let's integrate this, find the fundamental theorem of calculus, and then of course just take 1/24 of the end. So this is 0.005 t cubed divided by 3 plus 0.01 t squared divided by 2. It's just going to be a number crunching nightmare. T evaluated between 0 and 24, and do the fundamental theorem of calculus, and I think this turns out to be 1430 after you do that f of 24 minus f of 0, and then multiply by 1/24. Let's see if the author gets something similar. Yep, and they even showed you what that turns out to be. So make sure you can get the 341.52 after you do the fundamental theorem of calculus. Even and odd functions are kind of interesting. If it's an even function, they're saying instead of integrating from like -3 to +3, that's the same thing as integrating from 0 to 3 and just doubling it, because this area in blue is exactly the same area as over here in green. So instead of doing from -3 to 3, we can do 2 times. So that's kind of a neat little trick for even functions. For odd functions, strangely enough, this area here is the negative area, and this area over here is the positive area. And if it's again, you've got to be going from the same thing, from like -4 to +4, as long as there's symmetry about the origin. So if you're integrating from -4 to +4, the negative area will cancel with the positive area, and you should end up with a 0. So to determine if it's an even function, you replace x with -x, and then if it's the same function, then it really is even. That's just a test for even functions. If you replace x with -x and it's the opposite, then it's an odd function and it has symmetry about the origin. I call that the 3-0 rule. Right? Odd, opposite, and symmetry about the origin. So again, you double for the even and just go from 0 to a, and then the area for the odd function should be 0. There's a 4th O. So this, I can quickly see that this is an even function. So I could double this and integrate it between 0 and 2. I rarely use these, but you can. And then this is 2 times 1. If they tell you to use it, then you probably should. And evaluate that between 0 and 2, and you'll get 16/3. And this is an odd function, so I know that answer is just 0. And here's the author's worked out solutions. Nice. Oh, even if you forget, though, this is kind of nice. Even if you forget these definitions, you could work it out and still do the f of b. This is the f of 2 minus. So even if you forget these nice little definitions, you could just work through the problem. It just saves a little bit of time if you know about even and odd functions. The last thing I want to talk to you about is an annuity and how to calculate finding the amounts of some annuities. And here's a terrible formula for annuities, or at least it looks intimidating, but it's really not that bad. And I'll probably have to provide this on a test. I certainly don't expect you to memorize that formula. So if I provide this formula for the annuity and give you this story problem, we know that C sub t in this particular problem is this 2,000. That's the starting amount. So it looks like we've got a couple 15 years going on, and actually this 15 years is the same as this 15 years, but watch out. This 15 years is that green 15 years. We also have a small t, and that t is the variable. So we don't know what that small t is, but we know a lot. So let's see. Let's plug in what we have. E, the rate, is 5%, 0.05. The large t is this 15. And I'm going to integrate between 0 and 15, because whatever number that is, that's the same number. The C sub t is 2,000. E to the negative 0.05. And then I don't know what that small t is. But I'm going to integrate and then do the fundamental theorem of calculus between 0 and 15. So I will actually just pop out the 2,000 and then number crunch this. This is just some number. And then I'm going to integrate. The 2,000 got popped out. E to the negative 0.05 t, and then evaluate that between 0 and 15. So the integral of e to the negative, well, I don't have to, but it's easiest to think about a u sub negative 0.05 t, and then du says negative 0.05 dt. Divide by negative 0.05. Both sides. Well, I mean, I don't know how you want to number crunch because we already had this number. I'll just leave it. So it's 2,000 e to the 0.75. That's that number. And then it's negative e to the negative 0.05 t. That's that negative. Divided by the 0.05 because I had to divide this out. Negative. Divide both sides by negative 0.05. So that got... this dt is right here becoming my du. So this is, so sorry, this is just my e to the u. integral of e to the u and then du. And the integral of e to the u is just e to the u, but u is this. Remember, I'm divided by that. And evaluate this between 0 and 15. So then I'm going to do the fundamental theorem of calculus, f of 15 minus f of 0, and then multiply by whatever that number is. And again, do some quick number crunching, and I think you'll get something close. Of course, you want to check this. $44,680. You'll want to make sure that you can punch that on your calculator. Here's the author's explanation of this. Of course, this is posted on Blackboard, and he looks like he's got something similar. I would go through and practice these as well. The handouts on Blackboard. Work through these problems before you begin your assignment. Worked out solutions are here, posted on Blackboard. I know you don't want more problems to work out, but the more problems that you see, the better you'll get at these. So try to work out a couple of those. Even work out number 67. There's another annuity. I kind of blew it a little bit, but there's the c sub t, there's the rate, there's the capital T. Remember, the small t is the variable in this. So when you set this up for 6 years, you're going to integrate between 0 and 6, whatever number that is, that's this number. 250 e to the negative 0.08. This small t just stays small t. You're going to integrate that and then evaluate it between 0 and 6. So practice that and see, just pause the video and see if you can't get this answer. All right. I hope this video was helpful. If you have any questions, feel free to ask.